In today's lesson, we will be looking at how to graph exponential functions. We're going to answer these questions. What is the asymptote? What is the reference point? What are the key points? And how do we identify the difference between a growth model and a decay model? So let's look at these two graphs. In one example, let's look at the blue one or the green one. You'll notice that as we move to the right, so as x goes towards positive infinity, our graph increases at a rapid rate. So these are the exponential growth. Whereas the red graph, you'll notice that we start with a large value, and then as x goes towards positive infinity, that value decreases very rapidly and then begins to taper off. So we have two forms of exponential functions here. We have growth and we have decay. And in both of these functions, what is our asymptote? Remember that the asymptote is a line that our functions get very, very close to, but they never cross. If you looked at this graph and you thought that these lines were both approaching, or all three were approaching 0 when y equals 0, you are correct. So we do have a horizontal asymptote. No vertical asymptote, but in fact we have a horizontal asymptote. And that is at the line y equals 0. What about our reference point? Notice that all of these graphs, no matter if it's y equals 2 to the x, y equals a to the x, or y equals 1/2 to the x, they all cross this key point right here, which is 0, 1. So that's our reference point. But we also have key points that we use when we graph. So let's think about what our key points might be. Remember that when we look at key points, we always want to pick points that are close to the action, where things are changing. Well, we already know that 0, 1 is probably a key point. So we want to choose a point just to the left and just to the right so we can ensure that we get this curve right here. Well, let's go ahead and look at 1. If we choose 1, let's look at the blue graph here, the blue function. If we choose 1, then our y value is 2. Let's look at our green function, 8 to the x. If we choose 1 there, our y value is 8. What about our red graph? If we choose 1 there, then our y value looks to be 1/2. So are you seeing a pattern? Let's look at some more graphs. Here's 4 more that I've graphed. So we've got y equals 2 to the x, 4 to the x, 8 to the x, and 20 to the x. Notice that we all have this 0, 1 as our key point for these graphs. But what about 4 to the x? So if we choose 1, then you'll notice the green graph goes through here at 4. If we look at the 8 to the x, and we can move this down, if we choose 1, in our purple graph, notice that it hits here at 8. So we can determine that whatever this number is here in front of the x, that's what's going to be the y value when we plug in 1. Well, when we write this function, we can write it as y equals b to the x. Anything that is b to the x is considered a parent function, so the b value can change. It can be 2, it can be 8, it could be 1/2, but as long as it's just some value raised to the x power, it's considered a parent function. So when x is 1, y will always be b. Let's look at -1. It's a little bit hard to tell on this graph, but if x is -1, think about your properties of exponents. If you raise a base to a negative power, it causes that power to reverse or become the reciprocal of. So it becomes 1 over b if you raise it to a negative power. So if we plug in -1, our y value will always be 1 over b. Look, for example, at this graph here, the red one. This is y equals 1/2 raised to the x. If we raise it to the -1, it becomes 2. So if we look at -1 here, it intersects right here, where in fact y is 2. Now we have our key points that we can use regardless of whether we have a growth model or a decay model. So how do we identify the difference between these two models? Well, maybe you already have identified. Notice that anything that has a integer greater than 1, like 2 or 8, or in our other example, 4 or 20, we have a growth model. But here we have a fraction, 0.5 or 1/2, and notice that it's decayed. Identifying those differences, then we can say that if our b value is greater than 1, we have a growth model. If our b value is between 0 and 1, we have a decay model. Notice our domain and our range. Our domain in both of these examples is always all real numbers, negative infinity to positive infinity. Look at our range. Because of this asymptote, our range is also the same. It goes from 0, but we don't hit 0, and we go all the way up to positive infinity. Now let's look at what happens when we have transformations. Geometric transformations are the same in all your parent functions. And if you'll notice on this lesson, you have a new parent function that you can add to your parent function portfolio or your parent function library. Here is the general form with transformations. Remember that on the end here, this k is a vertical shift up or down. That would then obviously affect our horizontal asymptote. As our graph shifts up, our horizontal asymptote also shifts up. That would indeed then move our reference point. What about h? Well, h is next to x, and that represents our horizontal shift left and right. And it acts the same. If it's negative h, we actually move to the right, versus positive h, which moves to the left. And then again, our reference point will adjust as well. But when we have a horizontal shift, we have no effect on the horizontal asymptote. Let's look at reflections. We actually have a new reflection. We have our typical reflection here. If a is negative, in other words, there's a negative sign in front of a, that's the same thing as if we started with a negative y and we moved that into the right side of the equation. So that means we would have a reflection over the x-axis. But what happens if we have a negative up here by the x? Well, if we have a negative x, that reflects over the y-axis, and we'll try an example. And finally, we have a stretch or shrink, and that's our a value. Let's try 3 examples. We're going to take this function and we're going to graph it using our key points and our transformations. So if you'd like to pause the video and give it a try on your own, go ahead and then we'll come back and work it together. For this first example, it's very important that you identify the parent function. So I wrote out y equals 2 to the x. Remember that the negative 3 or the minus 3 and this plus 1 here, those are part of our transformations. Our parent function is just whatever the b value is to the x. So here's my key points. Now all we have to do is transform those points. Well, what does this 1 do? Well, it doesn't matter if it's at the front or the back. That's an adjustment to our horizontal asymptote or to our y value. So we have plus 1 here. The negative 3 here means we adjust our horizontal, and so we plus 3 here. Now we can just add those to each of these points to get our transform points. Now that we have our points, we can plot those. But very important, before you connect the dots, make sure to put in your asymptote, your horizontal asymptote, which we know has shifted up by 1. So we can always say that our horizontal asymptote is going to be whatever our k value is. Our horizontal asymptote will always be y equals k. And since k in this case is 1, we know we have this horizontal asymptote at y equals 1. We want to make sure to put that in because just like rational functions, this is a guideline for helping us to graph and identify our exponential growth or decay. So in this case, we have exponential growth, we have our asymptote, and now we can identify domain and our range. So remember that our domain is never going to change. It's going to be negative infinity to positive infinity. But our range will adjust depending upon our asymptote. Since we have an asymptote now at 1, our range goes from 1 to positive infinity. Let's try a second example. In this example, if you again want to pause the video and give this a try on your own, go ahead and then we'll come back together. The first thing you should have done is write out the parent function, which is y equals 3 to the x, and it's not negative x because remember this negative here is a transformation. Here's our initial key points, and then if we transform, what does this negative x do? Remember, anytime we start from positive and we go to negative, or vice versa, we're reflecting over y. So this is a reflection over the y-axis. Now we have this plus 1 here, which means we subtract 1 from all of our x coordinates. Now that we have our transform points, I can plot these points. Our horizontal asymptote did not shift because we do not have any k at the end. So it's still at y equals 0, but look what happens to our function. Our function has been reflected over the axes, and so now it's below the horizontal asymptote instead of above it. And that makes sense since we have a reflection over the y-axis. Our last step would then be to identify our domain and range. Our domain is always negative infinity to positive infinity, but now our range goes from negative infinity to 0. Let's try our last example. Here's our final example. Again, try this one on your own. Think about what your parent function is and your transformations. Try to graph this, and we'll come back together. Now in this example, our key points, we have the same format. But remember that if we take 1/2 to the negative 1, we take the reciprocal of this, which is 2. Now let's look at our transformations. For our transformations, we don't have any transformations that affects the x value, but we do have 2 that affects y. We have the 4, which is a stretch, and we have the -3 at the end, which is a translation down vertically. Adjusting our key parent function points, we get this new set of points here, which I have graphed. Now notice this looks different. What's going on? Well, if you look at our b value, it's a fraction, so now we have a decay model. But you can see that without our horizontal asymptote, this would be hard to figure out how to graph. Well, remember that our horizontal asymptote is just going to be the k value, which is -3. So we know that we have a horizontal asymptote here at y equals k, or in other words, y equals -3. Now we can take and graph our points more accurately as we know where the guideline is going to be. And our last task is just to identify the domain and range. Again, domain never changes, and our range goes from our asymptote and it goes up to positive infinity. And this concludes our lesson on graphing exponential functions. So at this point, you should be able to graph an exponential function using these key points. You should be able to identify the reference point in each of the key points, and then also identify the horizontal asymptote as y equals k. Finally, identify the difference between the growth and decay models.